Good day, grade 7 students. I am Sir John, and I will be with you as we study about science. Tara, let's learn together. In today's lesson, we will be talking about light, which is a part of our lesson for the week 5 to 6 of 3rd quarter. The most essential learning competency indicated in our pivot for a budget of work is explain the color and intensity of light in terms of its wave characteristics. Today's lesson is from Pivot 4A Learner's Pocket, which is used by grade 7 in Calabarzon region. Special thanks to Miss Wendy P. Villanueva from Region 4A for sharing your expertise for the content of this lesson. Here on Earth, light is very important. For without light, the plants can be able to produce foods for us through the process of photosynthesis. Light comes from two different sources, natural and artificial. Natural source includes the sun and other stars in the universe. The sun does not just give us heat, but also light. Other sources include bulb, lamp, and candles are considered the artificial sources because they are man-made. During Christmas season, people from different places love to visit different light shows. One of the most gorgeous light attractions is the giant Christmas tree found in Kartilyan ng Katipunan movement in Manila. The giant Christmas lights are so attractive that people take selfies in the park. The spectacular colored Christmas lights that move and change aim to ignite Christmas spirits, and this brought so much joy and relaxation to many tourists. Try to answer these questions. Number 1. Is the light from the Christmas tree natural or artificial? Number 2. If it happens that you are watching the light show and a group of people taller than you stand before or in front of you, would you still see the lights? Why? When you see sunlight, amusement park lights, and fireworks, you know you see light. They are forms of visible light. But you do not probably think of X-rays, microwaves, and ultraviolet rays as forms of light. They are forms of invisible light. Visible lights consists of light waves with frequencies between 430 trillion Hz and 760 trillion Hz, while invisible light has light waves with frequencies of less than 430 trillion Hz or greater than 760 trillion Hz. Light is made up of a stream of photon or tiny pockets of energy. The amount of energy in the photon determines the kind of light wave produced. For instance, photons of visible light contains a moderate amount of energy, while X-ray photons contain more energy. Light as a wave is both transverse and electromagnetic. Unlike sound, light, like all electromagnetic waves, can travel in vacuum. It travels in straight lines as evidenced by shadows and eclipses. Light as transverse wave vibrates perpendicular to the direction of the propagation. We can describe light according to its characteristics. First is about the brightness or the intensity. The measurement of the brightness of a light source is called photometry. For the second characteristic, we have color, and that is determined by the wavelength of the light wave. Intensity is the amount of light produced by a light source. It is often interchanged with brightness, but it is objectively measurable as the rate at which energy is delivered to a surface. Brightness, in the subjective quality of light, depends on how someone is viewing light. However, in the quantitative aspect, the luminous intensity or the brightness of a light source is expressed in a unit called candela. White light undergoes dispersion through a prism. Dispersion is a phenomenon in which white light separates into its component colors. It was discovered by Sir Isaac Newton during 1666. Christian Huygens postulated that the more light was bent or refracted by a substance or material, the slower it would move while traversing across that material. Max Planck postulated that electromagnetic radiation is a form of energy with both wave-like and particles-like properties. Visible light is a part of this radiation and can be described in terms of its frequency and wavelength. The theory of electromagnetic radiation was demonstrated by James Clerk Maxwell that electric and magnetic fields travel through space as waves moving at the speed of light. The 7 colors include red, orange, yellow, green, blue, indigo, and violet, which are also known as Roy-G-Biv or the colors of the rainbow. Among the 7 colors in the table, the violet has the frequency that is the highest, but the shortest of wavelength, while red has the lowest frequency, but with the longest wavelength. It is obvious here that the frequency of light is indirectly proportional or related to the wavelength. As the frequency increases, the wavelength decreases. These are the reasons why red colors have been used mainly as colors in various commercial logos. The color of the object we see depends on the light reflected in the case of the opaque materials, or transmitted in the case of transparent materials that reaches our eyes. Recall the visible spectrum. It consists of different frequencies, each corresponding to a particular color. For example, a green leaf appears green because when light from the sun shines upon it, the leaf absorbs all of the frequencies of the visible light spectrum, except for the green. Thus, a green leaf will be seen. By using the picture in the screen, determine which frequency of light will be reflected and what color will be seen by the observer. As for our summary, Max Planck explained that the light can be a particle and a wave. Light exhibits various characteristics. As a wave, it is a transverse wave in terms of direction of vibration and propagation. Brightness of light depends on the source and the distance from the source. This is expressed in the unit of candela. The electromagnetic waves are arranged in the electromagnetic spectrum according to increasing wavelength. Among the waves, the perceptible wave is the visible light. Visible light is composed of different colors abbreviated as Roy-G-Biv, also known as the colors of the rainbow. This has been proved by Sir Isaac Newton, in which he used a prism to separate white light into its component colors. This phenomenon is called dispersion. The color of an object we see depends on light reflected or transmitted. As we end, light has proven its integral part in our life. For without light, everything will be pure darkness. In the book of Genesis, the Lord noticed that everything was dark, and He said, "Let there be light." And there was light. In the book of Matthew, it is stated that you are the light. What does it mean to be a light in the world? That ends up our lesson for the day. I hope you learned something from this video. Thank you for watching. Please do like, share, and subscribe. We'll see each other again for our next video. Keep going and keep learning.